Welcome back to Inside NPS here on the Pentagon Channel. Well, recently the Naval Postgraduate School, in conjunction and association and collaboration with Hartnell College in nearby Salinas, developed a summer intern program. We had a chance to talk with some of the NPS professors involved as well as some of the Hartnell students.
My friend told me about an internship class that he had enrolled in, and I didn't really know what it was about, but I knew that he had been in an internship before, and I thought that was really cool, so I figured I'll take it. And I took the class, and my professors were really great, and it turns out they knew people at NPS, and one thing led to another, and I got an internship there. It seemed, upon entering the course, it seemed as though they were just preparing us. They were telling us what we would need to know in order to be able to succeed and communicate in a scientific community. But over the course of the actual class, it became obvious that, oh wait, they know that we're going to be in internships. All of us went to an internship. We had a sort of a speed dating thing, and we'd have a one-on-one, about 2 to 5 minute conversation with a random professor, and they would tell us a project they were doing, and the whole point was to get to know the professor and for the professor to get to know you, and if you got along and you were interested in the project, then that's what you were going to do.
It's a project that has a very basic physics in it. It's based on this toy, on the which is called the Crooke Radiometer. It's a set of 4 vanes that would rotate when illuminated by either sunlight or an incandescent lamp. And the physics that is behind this little toy has a fabulous historical background. Very important people had been involved with it. Einstein, one of them. Maxwell, the person that came up with the theory of electricity and magnetism. Crooke himself, and then all these really big figures in the field of kinetic theory of gases and thermodynamics were fully involved in it. And while the toy is simple, the physics is very, very complex. And so one of the things that I was trying to sell to the potential interns was a way to approach the different aspects of the different mechanisms that are involved in the device that make it work, and try to isolate all those different components, contributions. So when I was trying to sell this to Aaron or other intern, I had to make it to them as a splashy kind of topic, so that they would come back with interest. In the case of Aaron, he came back with questions. More than interest, it was a series of questions that reflected a lot of the insights that he had and that he actually brought into the project. Once Aaron came into the lab, we discussed the 2 ways to isolate the 2 main mechanisms responsible for the motion of the vanes when illuminated by an incandescent light. And the dedication to the project that he had was amazing.
I had never actually, it's very different to work on a real life project than something you do in school, because you set your own goals. You are your own boss, and I think that's the most liberating thing about it. Originally, the plan was to just identify the driving forces, but eventually the project became applying them. So now that we've identified what the mechanism is, now we can conceivably harness that power, and hopefully to power something. And I think it's really exciting.
This is the work of Aaron, and this was something that he would carefully spend hours on it, drawing the slots, cutting them, making sure that there was a good deposit of blackness on one side and white on the other side. You cannot get you cannot get that kind of dedication without internal motivation. And what fascinated Aaron was that he was coming into a project that had a lot of basic physics built in, and that had a lot of questions unanswered, and that he was going to provide with his hard work and insights. He was going to provide venues of understanding the mechanisms much better.
Originally, we didn't know how to behave around each other, and because one, he didn't know how far my education in science or math was, and I was afraid to ask a dumb question, but it turns out that the dumb questions are the ones that help us get further, and it's actually what helped the project kick off even faster. If I hadn't suggested, well, why can't we just print black on a sheet of paper, on a sheet of photo paper, then we would probably still be trying to apply the carbon nanopowder to it.
In the case of Aaron, I think I see him as a day-by-day kind of person. He builds from the experience of the day. At least that was how I saw him in the lab. And as a student in Hartnell, he's probably just doing the same thing. Just getting involved with his courses one at a time, and trying to extract an experience out of that.
Anyone can do it. Anyone can. It's not that it's easy. It isn't easy. It takes effort, and you have to be ambitious.
We have a unique opportunity, and we have to really nurture it. We have students that are excited, but their excitement is not raw. I mean, it comes with interactions among themselves. They come here after being negotiated in a classroom, where they have been told what are the main protocols that they have to approach when it comes to basic research or applied research. I think I probably benefited a lot more than he. I hope he can pursue a little more of this project.
I'd say that my time at NPS has helped me realize that I do want to get a career in research.
Well, obviously, we're off to a great start with this summer internship program between Hartnell College and the Naval Postgraduate School. We'll be bringing you more success stories in the months ahead.